So today we are going to implement GLBP over here. Gateway Load Balancing Protocol, as I discussed in previous class, that it is that protocol which can provide you gateway redundancy along with the load balancing. Before GLBP, we were having some other gateway redundancy protocols as well, such as HSRP, VRRP was there, right? So HSRP and VRRP, they can provide you gateway redundancy, but it was not possible for them to provide you load balancing. So basically, GLBP can provide you gateway redundancy along with load balancing, right? So basically, in previous class, I told you that in GLBP we are having two main components. One is known as AVG, another one is known as AVS. AVG, for AVG, only one device will be active and one will be standby, and all others will be in listen state if you are having more than that, right? Like right now, I'm having only two devices over here in my lane segment. I'm having only two gateways. So of course, for AVG, anyone out of them will be active and another one will be standby. And one more thing over here, I would like to tell you that the election for AVG, active virtual gateway, right? It will be same as it is completely same as HSRP, no difference at all. The election process of AVG, right? Like for AVG, they will be active, they will be standby, and all others will be in listen state. And the election of active and standby will be same as HSRP. No single difference. Like first of all, for AVG election, preemption is by default disabled, same as HSRP, right? If you enable GLBP on all devices at same time, then definitely for AVG election, priority will be considered, and if priority is common, then higher IP address would be considered, right? So it will become active. But in case if you enable GLBP only on one router first, then it will become active for AVG, and it will always remain as active until it goes down, right? So the election of AVG is same as HSRP. Now the point is, what is the responsibility of AVG? As I taught you in previous class, that AVG will be responsible to provide ARP replies in the response of ARP requests. Is not it? AVG will be responsible to provide ARP replies in response of ARP requests based on configured load balancing algorithms. Now for AVG, there are multiple load balancing algorithms available in GLBP, such as round robin, which is by default. Weighted is also there, and apart from that, host dependent is also there, right? So I'll be first of all, see, by default here, load balancing algorithm is what? Round robin. And see, one more thing that I would like to tell you here, that GLBP does not perform a load balancing based on per packet or something like that, like router does. Routers performs load balancing per packet, like right? Because by default, control plane will always perform load balancing based on per packet basis, is not it? But it is not the same thing in GLBP, because GLBP actually it will be performing load balancing based on ARP requests. Like if any one of the hosts have generated a ARP request, then of course the active router for AVG will be responsible to give ARP reply. So in ARP reply, it will give the MAC address of one router, then in next ARP reply it will give the MAC address of next router, in next ARP reply it will give the MAC address of next router. You can have maximum 4 forwarders. You can have maximum 4 forwarders in a single group. Right now, and one more thing, that all gateways will participate actively as forwarder, but not more than 4. Because you can have maximum 4 forwarders in a single group, right? AVG is different thing, right? AVG is different thing. AVG is just responsible to provide ARP replies based on load balancing algorithm, but AVF will be responsible to forward your data, right? So all of them will become AVF, all of them. Like if you enable GLBP first onto one router, it will become forwarder 1, then on next forwarder 2, next forwarder 3, then next forwarder 4. You can also have more than 4 forwarder, but the problem is that it will not participate in your GLBP.
So sir, जो AVG है वही AVF बन सकता है?
Of course, even AVG itself will also be any AVF, whether it is forwarder 1 or forwarder 2 or forwarder 3. See, AVG will be 1, whereas all others will, whereas all routers will work as AVF. But there will not be only one AVF, no. There will be multiple VRF as per number of gateways. If you are having 2 gateways, there will be 2 AVF. If you are having 3 gateways, there will be 3 AVF. If you are having 4 gateways, 4 AVF. So of course, it's mandatory that AVG itself will also work as a forwarder. I mean, can work. It's not mandatory, because it is not possible that for all forwarders will work as AVG. But yeah, if he enables GLBP onto one router, then definitely it will become now active for AVG, as well as it will become forwarder 1. And for forwarder, there is no standby state. Let's say that R1 have become forwarder 1. Its physical MAC address will be bind to forwarder 1, right? Its physical MAC address will be bind to the forwarder 1. And of course R2 will become forwarder 2, and its physical MAC address will be bind to forwarder 2. One more thing, for forwarder 1, R1 will be active because it is the actual forwarder 1, right? And R2 will be in listen state. There will not be any standby, right? In same manner for forwarder 2, R2 will be active, whereas R1 will be in listen state, which means that all routers will be having all forwarders information in their database. All routers will be having all forwarders information in their database. So right now AVG, let's say for AVG R1 is active, so it is having information about both forwarders, forwarder 1 as well as forwarder 2, right? So whenever it will receive any ARP request, in ARP reply, first of all it will give the MAC address of forwarder 1, then in next ARP reply it will provide the MAC address of forwarder 2, then in next ARP reply it will provide again MAC address of forwarder 1, and in next reply again it will provide the MAC address of forwarder 2. Once again forwarder 1, forwarder 2, forwarder 1, forwarder 2, but as per number of as per ARP requests. Right? I hope you people have understood all these things till now, right? And it will be using UDP port number 3222, and multicast address is 224.0.0.102 itself, 224.0.0.102, which was used by XSRP version 2 as well. Fine, let's configure it now. I will start it from R1. Want to accept 0 by 1, I'll say GLBP. How many groups can be configured? 1024. I took 1, then IP, and then virtual IP, which it is going to be. It's not it. Fine. I'll show you that now this R1 will become active for AVG as well as it will become forwarder 1. Just wait for a moment, because hold down timer is what? 10 seconds. So accordingly it will take some time over here. It is still in listen state. Speak. Finally active. For AVG. And it will also become active for forwarder 1C. You see, the state is virtual IP is fine. This is your virtual IP, this is your hello interval and hold down. Redirect timer is also there in AVG. Redirect timer is 600 seconds, whereas forwarder timeout is 14,400 seconds. I'll teach you that what is the uses of redirect timer over here and what is the use of forwarder timeout. And by default, preemption is disabled for AVG. See, up from here to here, this information belongs to AVG only. This information belongs to AVG only. And after that, it is having information related to forwarders. So preemption is by default disabled, active is local for AVG, standby is there is nothing, priority is by default 100, waiting is also by default 100, thresholds as it's like 1 and upper is 100, load balancing algorithm is by default round robin. There is one group member, its physical MAC address is this, and this is the IP address of that, and this is local device. There is only one forwarder, and for that forwarder itself is working as active. For forwarder 1, its state is active. MAC address for GLBP up to here 0007 B4 B4 up to here, it will be reserved. The next 4 digits will be responsible to define your group ID. Next 4 digits will be responsible to define your group ID, as we took 1, so it is 0001, and last 2 digits will be responsible to define your what? Forwarder. Last 2 digits will be responsible to define your forwarder ID. So this is forwarder 1, that is why it is 01. Owner ID, this is the physical MAC address of this forwarder. As I said, that the physical MAC address will be bind to your forwarder, right? So that in case if R1 goes down, then R2 would definitely become active for this forwarder 1, right? But in case if R1 comes back up, you understand? How will it be possible for it to that now that I have to be active? So it will find that okay, I'm the primary one, right? I'm the primary one. So if I'm up, it means I must be active. So it will preempt the role of active for forwarder. So remember that for forwarders, preemption is by default enabled, but for AVG preemption is by default disabled. And there is no election for forwarder actually, because for forwarder 1, like you enable here forwarder, you enable here GLBP, so it became forwarder 1. If you enable GLBP onto any other router, it will become forwarder 2. If you enable it onto another router, then it will become forwarder 3. Right? You understand? So these things are there. So there is no like election, something like that. My God, just give me 1 moment, please. Fine. So now this is forwarder 1, right? I'm going to enable GLBP on 2 now. I'll say GLBP interface fast Ethernet 0x1. I'll say GLBP 1 IP 192.168.101.100. Make sure once again. Now here make sure that you are taking same virtual IP 101.100, right? It's mandatory. See, now I'm on to R1. Let's move on to R2 now. Actually, it will become active for forwarder 2. See, show GLBP. For AVG, it is standby. There are 2 group members, which means there will be 2 forwarders, right? Because there are 2 forwarders, forwarder 1 and forwarder 2. For forwarder 1, it is in, this is the MAC address of that, this is the owner ID of that, this is TTL, this is preemption. By default minimum delay is what? 30 seconds. Active is 101, which is primary, right? And the weight of the primary is by default 100. This is forwarder 2, for it is active, and this is the MAC address, MAC address, this is virtual MAC address, right? And this is the owner ID, this is preemption delay, active is local, and our weight is 100. As you can see over there inside the AVG itself, that our weight is by default 100. So see, this R2 have become standby for AVG, but it have also become at same time it have also become forwarder 2, and forwarder 2 it is working as active. What? Time to leave.
Second.
Yeah, it is second. It's not hop count. This is not the TTL value of IP header. I'll let you know that what is the uses of that, right? Now the point is, like, let's move on to host, and on to host I have to allocate an IP address like 192.168.101. Tell me 10 and fine, and then I'll say no IP routing. Then I'll say IP default gateway is going to be 101.100. It's going via R1 because it have got the MAC address in ARP reply of forwarder 1. So every time now it will go via R1. Show IP R. Check it out. 0101, which is forwarder 1, right? As you can see onto R1. Show. Tell me GLBP. There are two forwarders. Forwarder 1 is having its MAC address is this, and forwarder 2 is having this MAC address. Last two digits will get changed because this is working as forwarder 2, right? Now move back again onto host, and then how can we prove it? Now we must have another host, right? But right now I do not have another host, so I cannot verify my load balancing, right? To verify that, what can I do? I can clear its ARP table. So what will I do? I'll shut it down, and then once again I'll say no shutdown. So that will flush its all entries from its ARP table. See, except it's on. And then right now again again I will trace route 1111, and this time it should get the MAC address of forwarder 2 in ARP reply. See, show IP ARP, and once again trace route. It's going via R2. Now next time, see, whenever you will shut it down, you will flush its ARP table, it will generate ARP request, right? So basically AVG is giving ARP reply based on load balancing algorithm. It was round robin, right? So no shutdown once again, and once again it will generate ARP request. This time it should get the MAC address of forwarder 1. So sometime what will happen, that for an example I got the MAC address of forwarder 1 and I'm generating too much traffic, and Balaji got MAC address of forwarder 2 and he is generating very low traffic. So of course on forwarder 2 there will be very less traffic, right? So you cannot say that it will perform 100% load balancing. No, never. Trace route. This time it should go via R1. Once again, and then say it's not it. See, it is performing load balancing in round robin way, right? FA0 by 0, shut it down, and then once again say no shutdown. It's going via R1. Fine. Now in case, see, it is performing load balancing by default, right? Now in case if R1 goes down, sorry, if R1 goes down, show GLBP. See, it is in init state. For forwarder 1 it is also in init state because interface has gone down. Let's move on to R2 now. It will become active for AVG because it will be responsible now to provide ARP replies, and also it have become active for forwarder 1. See, and once it will become active for this forwarder, it will immediately generate a gracious ARP. So that switch will update its MAC table immediately. So now you see that this host was having the MAC address of forwarder 1 in its ARP table. It doesn't mean that now its traffic will start to get dropped. No, it will go. The traffic of this host will start to go via forwarder 2 now. Like you can trace route. Still it is having the MAC address of forwarder 1, right? One more thing I would like to show you over here. If your forwarder 1 is not coming up for a long time, Will it be good for this AVG to provide the MAC address of forwarder 1 in ARP replies? Yeah, for some time it can work. It can provide the MAC address of forwarder 1 in ARP reply, but not always, right? It should not happen for always. That is why whenever a secondary router will become active for forwarder, see, this is secondary, right? It is not primary, right? Hello. This is the owner ID and this MAC address belongs to R1. Active is local. So basically right now secondary device is active for forwarder 1, right? Not primary one. Are you getting my point? So it should not be active for always. That is why there is a redirection timer. Whenever a secondary device becomes active for forwarder, it will, your AVG will immediately start redirection timer, which is by default 600 seconds, which means 10 minutes. Means that up to next 10 minutes maximum, it can provide the MAC address of this forwarder 1 in ARP replies. If the primary device does not come up for this, of this forwarder, then after 10 minutes, AVG will stop to provide the MAC address of forwarder 1 in ARP replies. But still it will keep that forwarder in its database. Then after expiration of redirection timer, it will start your TTL, time to leave, which is 14,400 seconds, something like that. 14,400 something like that, right? It will start that timer, which is by default 4 hours. This timer is 4 hours, right? Let's say that this host, this PC end user, lane user, got the MAC address of forwarder 1 in ARP reply. Now forwarder 1 has gone down, but still there should be some device which can still accept the traffic with that MAC address, which was allocated to forwarder 1. So because this host will keep its ARP entry in its ARP table for maximum 4 hours, that is why GLBP will keep that forwarder in its database for maximum 4 hours. So that if this lane user generates any traffic, then that router can accept this traffic. Otherwise, see what happens that whenever you receive a frame, first of all you check its destination MAC address. If it does not match with your own MAC address, it will simply discard it. Right? So now do one thing. Let's move back again onto R1 and onto FH0/1. I'll say no shutdown. Now it will not become active for AVG because by default preemption is disabled, and of course even it is having they are having same priority, and higher IP address is configured onto R2. So this time you will see that now R1 will be standby for AVG, but it will become active for AVFC. But it took so long time because by default preemption delay is what? 30 seconds. So now once again this R2C for forwarder 1, it have moved back into listen state. See, from active this R2, and once again its active is now what? Primary. Are you getting my point? So once again from the lane user, see, it was still having in its ARP table, still it is having the MAC address of forwarder 1, but this time its traffic will go via R1. because now R1 itself have become the active for that MAC address, right? For that forwarder 1, and this host was having the MAC address in its ARP table of forwarder 1. So it has proved that it is working in this manner, right? Now I will prove the uses of redirection timer. What will I do? I will change redirection timer. I will make it lower than 600, right? So that we can prove that rapidly. So interface fastest net 0 by 1. I'll say GLBP 1 timers redirect can be in between 0 to this one. So I'll make it 60 seconds, right? And then timeout is 660. So I can make it 1000 as well. Fine. Show GLBP. I changed it over here. I changed this timer over here only, but you see, oh, it is saying that you have to make changes over the onto that device which is active for this AVG, right? So F0 by 1, just remove this command from here, do show history. I'll configure the same thing over there. See, it is just for a minute. Give me just a second. See, it shows GLBP now. There will not be any problem now, right? And it will update its neighbors automatically, like R1. It have also configured its redirect timer as 60 and timeout is what? 1000. Hello? Understood? Now what am I going to do now? I will move on to R1 and once again I'll shut down its 0 by 1. So see, from the host, do one thing, just shut it down, say no shutdown, do trace 1.1.1. So it's going via, see, R2 and once again say shutdown, once again say no shutdown, once again say trace route. This time it should go via, but show IP ARP. See, this is the MAC address of forwarder to itself, right? Then go to interface F0 by 0, shut, no shut, do trace, do show IP ARP, do show IP ARP. Check it out. This time it got the MAC address of forwarder, which means that, see, forwarder 1 has gone down, but R2 have become active for forwarder 1 now, right? Which means that AVG is still giving the MAC address of forwarder 1 in ARP replies. However, traffic is still going by R2 because for both forwarders, R2 have become active. So the traffic of both forwarder is going via R2, but still AVG was giving the MAC address of forwarder 1 in ARP replies. But now redirection will get disabled onto R2. Just wait. Show GLBP for forwarder 1. Yes, redirection is now disabled, and now you will see that AVG will never provide the MAC address of forwarder 1 in ARP replies. Let me prove it. I will move back again to host and again I will shut it down, and then again I will say no shutdown. Then I will say do trace, do show IP ARP. It got the MAC address of forwarder 2. Then again I will shut it down. Then again I will say no shutdown. So it must not get the MAC address of forwarder 1 now. Say do trace. It should go by R2. Of course, there is only one path available now, right? But check its ARP table as well. Again, it is having the MAC address of forwarder 2 only. So at this time, AVG have stopped to provide the MAC address of forwarder 1 in ARP requests. But still AVG will keep that forwarder in its database for next 4 hours. But this time I configured its timer as 1000 seconds. So now it will remove this entry after 846 seconds. Got it? So in this way it works actually. And once again I will move back onto R1 and I'll say come up. Now for AVG I want to configure this R1 as active. For AVG I want to configure it as a active. So for that purpose what can we do? We can move on to F0 by 1 and then I'll say I can say GLBP 1 priority is what? 101. But still it will not become active because by default preemption is disabled. So say GLBP 1 let me show you. Show GLBP. For group 1, not for AVG. For forwarder 1 it became active. See, for AVG still it is standby, but for forwarder 1 it has become now active. Show, now see, interface F0 by 1 and GLBP 1, what? Ping. Show GLBP. Check it out. Now it has become active. See, for AVG as well. It has become active for AVG as well now. Right? Fine. We have seen that there is redundancy as well as, of course, there is load balancing, right? Now the point is, if onto R1, it's when interface goes down, what will happen? It will remain as active, and whoever will get the MAC address of forwarder 1, its traffic will get dropped, because it is working as AVG. It will keep on to give the MAC address of forwarder 1 in ARP replies. So whoever will get the MAC address of forwarder 1, that traffic will get dropped. So let's move on to this host. Say shut and then say no shut. Do trace once again, shut, no shut, and then do trace. Wow, this time it got the MAC address of forwarder 1. It's reaching forwarder 1, but that forwarder 1 do not have path, do not have route to reach your destination, right? That's why your traffic has been dropped by forwarder 1. Have you understood it or not? For sure.
Yes.
Fine. Now, to solve this problem, tracking is there. Onto R1, let's move back again onto F0 by 0. Say no shutdown. Check show GLBP. By default, its waiting is what? Actually, in GLBP, the uses of priority is just for the election of AVG, not for any other thing, not for any other purpose. In GLBP, we are using priority just for election of AVG, not for any other task. So here priority will never take place in terms of tracking or load balancing, never. For that purpose we are having here waiting, which is by default 100 onto all, which is by default 100 onto all. Now see, lower threshold is what? 1 and upper is 100. If it reaches its lower threshold, remember that if any device reaches its GLBP threshold, lower threshold value, then it will become ineligible to become forwarder, to become active for that forwarder. Let's say this R1 is forwarder 1. Hello, R1 is what? Forwarder 1. If it's on, weight value reaches lower threshold, then it will not become, or it will not be eligible to become active for this forwarder. Understood or not? We have to do that. By default, decrement in weight will be 10, so it will not reach its lower threshold. So you have to modify your decrement value as well. For doing that, I'm going to perform it now. I'll configure a track object. What should I do? ICMP core, or what do you want? Route or what? Route. So I'll say track directly 10 IP route, which is subnet mask, and then you have to verify its reachability. Then go to interface F0 by 1, say GLBP 1 waiting track was 10. Decrement, it should be at least what? Make it 100, so that its weight will become 0, so it will become ineligible to become active for this forwarder, right?
1/2.
Of course, because lower threshold is what? 1. Check it out. State is right now. Now do one thing. Just shut it down. So now your track object has gone down. Reachability is down. Show GLBP. Now for forwarder 1 it is what? Active. You know why? Because minimum preemption delay is what? Yes. So it has to do wait for remaining 18 seconds, and then after it will become active. Just wait, and you cannot change this preemption delay. No, you can define preemption delay for AVG but not for forwarder. See, now forwarder 1 have become, which means R2 have become active for both forwarders, right? So in this way you can define what? Tracking. Fine, guys. So once again onto R1, if you see that F0 by 0 has, this is its actually WAN interface, right? As you can see, WAN interface. So say no, shut down. So again it will come up, it will form neighborship. That route will be available in its routing table. Reachability will come up, which means that track object will come up. If track object comes up, then again it will add. See, but again preemption delay is what? So again it has to do it for that time. But finally it will become. You know why? Because it was the primary active for this forwarder, because its MAC address was bind with this forwarder. So it knows that it is itself primary forwarder for this forwarder 1. Right, guys? Show GLBP. Check it out. It have become once again. But the problem is, in case R2's WAN link goes down, then again there will be same problem, right? So you have to configure tracking onto R2 as well. Because for forwarder 2, R2 is active, and in case if its WAN interface goes down, then also it will keep, or it will remain as active for forwarder 2. So it will be mandatory for you to configure tracking onto R2 as well, like track object 1 IP route 1111 subnet mask, and then finally you say reachability, right? Then go to F0 by 1, say GLBP 1 waiting track 1 decrement of. So in case if it's when link goes down, then it will also decrement its weight by 100. So its own weight will become 0, which means it will not be eligible to be active for forwarder 2. So in that case, R1 will become active for forwarder 2. Let me show you. F0 by 0. Sorry, interface is 0 by 1. 1 by 0. Just shut it down. So it will lost this route. Once it will lost this route, your track object will go down. See, it has gone down now. Wait, it haven't. See, once it will go down, then it will configure its weight as 0. See, show GLBP. Now its weight is what? Low. Is not it? Its weight is low. And if its weight is low, then it will not be eligible to become active for it. But R1 will take at least 30 seconds to print the role of active for forwarder 2. See, 6 seconds are still remaining. I hope you people have understood that why is it necessary to configure track onto all devices. See, it will become active now for both forwarders, right? Now if you move back again onto R2 and then we go to serial 1 by 0 back and then say no shutdown, you will see that neighborship will again come up. Once neighborship will come up, route will be learned, then your track object will come up automatically, and once again it will become active for forwarder 2. But preemption delay is what? 30 seconds. So it has to wait for 30 seconds before becoming active for forwarder 2. Right? Fine. So in this way you can configure GLBP with round robin. I've taught you the uses of timers like redirection timer as well as TTL, time to leave, which is also known as forwarder timeout. Forwarder timeout. So I hope that you people have understood the uses of GLBP over here, right? Then now there is a problem, like it is performing load balancing based on round robin, right? It is a problem because this is Ethernet link and this is serial link. So what I want that it should it should perform load balancing in ratio of 3:1. Means if it is receiving 3 ARP requests, in the reply of 3 ARP request, it should give the MAC address of forwarder 1, and in the response of 1 ARP request, it should give the MAC address of forwarder 2. It's not it. Hello. Because R1 forwarder 1 is having higher WAN bandwidth, so it can handle more traffic rather than forwarder 2. So it should perform load balancing in ratio of 3:1. So now to get that, by default with using round robin it is not possible to achieve it, right? So you can change your load balancing algorithm onto your AVG. So who is AVG here? Who is your AVG right now? I think R1, because I configured it as active, right? I enabled preemption as well. So now you do one thing, go to interface F0 by 1 and then say GLBP 1 and then say what? Load balancing, and see how many algorithms are there. So you have to configure now, wait it, and then in same manner I'll move on to R2. However, it is not necessary to configure it onto R2. It is not necessary, but in case if R2 becomes AVG, what will happen, right? So it will be good for you to configure, you understand, this command onto R2 as well. So now say GLBP 1, load balancing is what? Weighted, fine. But by default weight is what? 100. By default on both routers their weight is what? 100, which means again they will perform load balancing in ratio of 1:1 only. To solve this problem now, what will I do? What? Yes, I'll change it. So I'll move on to F0 by 1. I'll say GLBP 1 waiting, and then what? Like I'll make it 200 because I cannot make it 400, right? So 200, and then on to R2, what should I configure? 50. So GLBP 1 weighting 50. Fine. I configured weight in this ratio only. Are you not getting it? Sure. So now show GLBP onto R1. Check it out. That by default it's yes. You understand? And now make sure that its decrement should be like 200 now. During tracking, its decrement should be 200 now. Otherwise, your track will not work. I mean, your in case if that interface goes down, then it will remain as active for this forwarder. You understand? For forwarder 2, we configured over there. It's a TT. I mean, its weight as 50. So here I have this. I mean, all routers will learn this information actually. Like here, we are having our weight as 200. If you move on to R2, then R2 have also come to know that okay, R1 is having its weight as 200. But right now, because for AVG R1 is active, so AVG will be taking decision, right? So let's prove it now onto host 1. Have 0 by 0, shut it down. Say no shutdown. Do press is going via R1. Do show IPR. Fine. It got the MAC address of forwarder 1. Then once again shut. Then no shut. Do trace R2. This is what? R2. Shut. No shut. Do trace via R1. Shut. No shut. Let's check it out this time. Do trace R1. Shut. No shut. Wait, just a moment. Now it will go by R2. Do trace. Now R1 itself. Shut. No shut. R1. Do. Sorry. Shut. No shut. R2. Right? Then shut. Once again. No shut. R1. Shut. It will go in that ratio only, right? Do. R1. Shut. Do trace. Once again. Shut. R1. Shut. Right? Actually, it is going in this ratio now because we configured their weight in that ratio only. Of course, 250. So it was in ratio 4:1.
So what is light slicing?
What?
Client selection. So then,
I don't exactly know the meaning of it. This one. Sometimes it is 1, sometimes it is 2. You can search it out. Right? So in this way you can perform load balancing with using GLBP. Tracking is done, everything is done. So I hope that now you can perform all the practicals of GLBP by yourself, right?
host
What?
dependent. Third,
Host dependent means you will never use that. Once your host, if let's say that your host got the MAC address of forwarder 1, now every time it will get the MAC address of forwarder 1 only, because now GLBP will keep that track in its cache. That's the meaning by host. If you have got the MAC address of forwarder 1, you will always ever get the MAC address of forwarder 1 only. So we will never use that actually.
उसमें कोई load balancing ही नहीं है.
So basically we use this by default round robin, and in some cases you can also go for weighted. After it I am going to teach you configuration of DHCP. You understand? And I'll configure my DHCP server. See, I want that my lane users must get an IP address dynamically, right? And my DHCP server will be configured at the on core, right? I'll configure it on core. So I'll move on to core. Or if you want, you can exclude as well. Like you are using 101, like you can say IP DHCP. Right, let's move on to host now. Say debug and then say IP address. It is generating discover messages, right? It has generated discover messages. See, even I'll capture them. But it's not getting any offer. You know why? Because these discover messages are not going up to core. So now you have to configure relay agent. Because broadcast cannot across their broadcast domain. Broadcast messages cannot across their broadcast domain. See, actually DHCP discover are broadcast messages. You see. This is message type. Discover type 1. Client identifier. Host name. All these things, subnet mask, domain ID, right? We want all this information, right? So actually we are not getting anything from there. So now what will I do? I will move on to R1. R1 sub 0 by 1. Also IP DHCP. Sorry. And it is reachable from here, right? In same manner, I'll move on to R2. and now it must get an IP address. See, 101.3. It have got it. You understand? And see what was the process. Discover, offer was also broadcast, request was also broadcast, acknowledgement was also broadcast. But in acknowledgement you can see, and in offer, that source IP address is the
DHCP.
not DHCP ones, actually 101.1, the relay agent's address.
Yes.
You understand?
But जो helper तक आएगा उसके अंदर DHCP.
Exactly. You can also capture them. In source it will be here, relay agent's address, and destination will be course address, right? So in this way you can do that. Now let's say that I wanna always allocate my, to my host this 101.10. I wanna always allocate this IP address to this host, right? So if I move on to core, then I can say show IP DHCP binding. It is having this binding. So basically, if you do not see, if your user is router, then it will always show you that much long client ID. But if you move on to host, like if you are having a computer, then it will not be like that. You can say interface IP0y0 IP address DHCP, and client ID is my interface itself. I want to use my interface is MAC address as client ID, right? So now you will see that see 101.4 and see client ID is this. This is the MAC address of your host now, and this 01 will always be added in the beginning of the MAC address. Remember, this 01 will always be added in the beginning of the MAC address. These 2 digits are extra in your MAC address. 01 will always be added into the beginning of the MAC address. You understand? Now what I want, that it must get always 101.10. So I'm having this pool already over here. So IP DHCP pool. See? Is not it? Show run pipe section IP DHCP pool. Check it out. This pool is already there, right? I'll create one another pool, IP DHCP pool host, or whatever its name is, right? Now you can say client ID and just copy and paste it from here, because I said this one, because it got it from here. And if you cannot copy and paste from here, go there, copy MAC address of the host, and then add 01 in the beginning of the MAC address, and then just paste it under client identifier. Then say host at host, and then host address is going to be, and subnet mask. Tell me, default router is going to be, DNS server is going to be, fine. Even you can also allocate domain name.
इसको हम पूल से निकाल दें तो भी होगा लोकेशन.
What?
.10 को निकाल दें पूल से.
कौन से pool से?
DHCP जो दूसरा पूल बना है.
वहाँ से क्यों निकालोगे?
कि अगर लोकेशन हो रहा
हाँ, तो कोई बात नहीं. Show IP DHCP pool. Now there are 2 pools, right? There are 2 pools.
सर 2 pool किस लिए बने?
One is for particular host and one is for entire network. For reservation you have to create another pool, right? Within a single pool you cannot perform reservation. If you are doing reservation for more than one host, then you have to create number of pools. That number of, like if you are reserving MAC IP addresses for 4 hosts, then you have to create 4 separate pools.
Okay.
And there must be one common pool.
और अभी हमने जो क्लाइंट एंड पे जो अभी आपने रिक्वेस्ट करी थी वहाँ पे इंटरफेस की भी ऐड करा था ना?
Because it must take its interface's MAC address as client ID. Always. Once again configure the same command over here. So in T-shoot, if they are asking something like this, might be that on the host they will not add this client ID interface number, right? Or they will not create host. They can configure incorrect client ID. They can configure incorrect IP address. They can configure incorrect default gateway within the pool. See, it got 101.10. And now
DHCP to left.
press route 1111. See, it will go there. Tell me, any problem? So in this way you can allocate an IP address to your host, to your lane users dynamically with the help of DHCP. Now if you wanna see, my DNS server is also what? 111. I configured it, right? So onto core itself I can say IP DNS server to make a DNS server, and then I can say IP host, and then its name is like www.google.com and IP address is what? 111. Fine. Now I will move on to host. Here I'll say IP domain lookup, that is mandatory for me to enable here so that it can perform domain lookup, right? And then I'll say ping. Because in DHCP it got DNS server as well, DNS server's IP address. So it knows that where is my DHCP server. Sorry, DNS server. So it got resolved from there. See, domain server is 111. Even you can also have some other IP addresses onto core. Like onto core, you can create one another loop back. IP address is 2222. IP host. From host.
So इसमें DNS में नहीं होती प्राइमरी सेकेंडरी जैसे DNS में होता है.
You will not configure your routers in most of the cases as DNS server. In most of the cases, you will be having either Unix or Microsoft servers as DNS as well as DHCP servers. Right, guys? If I did not use this IP domain lookup onto this host, let's say I have said, it will not work. See, to say, even if I do not enable this DNS server command onto core, oh, they're using cache entry. It is saying that it is not there, but I'm using cache entry. Clear? Forget about it. But once you will say IP, I won't use cache entry. See? Okay. So it is generating name query, and then it is getting response from there. See, you can see that DNS, DHCP, ICMP, DNS, standard query, right? Standard response query went towards 111, right? Port number is 53, right? And then reply. See, this is the IP address, right? So, yeah.
IP एड्रेस में कौन सा IP एड्रेस होता है?
What IP address?
IP एड्रेस होता है उसको कौन सा IP?
DHCP
DHCP server's IP address. That should be reachable. You can take anyone. You could take 1.2. You could take 2.2, or I took 1.1.1. That should be reachable, right? And onto that device, pool must be configured. But remember that if you have configured pool from the different range, then it will not provide an IP address. Like here, the interface where you configured relay agent was having an IP address from the range of 101.1. Here it is having 101.1, right? So in source it will keep 101.1. So it will go to DHCP server, will look only for that pool which is having having network ID to which this IP address belongs to. If that DHCP server does not have that pool to which this IP address belongs to, then DHCP server will not be able to provide an IP address. Like let me prove it. I'll move back again onto core. Do show run pipe section IP DHCP. I will remove it, right? No this. No this. I will remove it now. Fine guys. IP DHCP pool. Name is test network 168.102.0/ fine. I'm having this pool now, right? Once again I'll move on to host, and then again I'll say get an IP address. This time it won't be possible for it to get the IP address, right? And also I'll show you onto core debug DHCP server packets. See, received through relay agent 101.1. But now you can also see debug IP DHCP server events. Once you will enable events, it will show you that it received a discover message, but it does not have the pool for that. What is it saying you now? There is no address pool for this address 101.1. So because information is coming of see, from 101.1. Are you getting my point? So it must have the pool in which it is having this IP address. So IP DHCP pool Cisco network 101.0/. Now it will get an IP address. See, this host will get an IP address. Don't worry about that. It's not it. So it does not mean that you can create any pool over there, no? Because information is going from here to there after relaying, and at least on that interface who is relaying your information, you must configure your IP address statically, and that we configured over here 101.1. Fine guys, so in this way you can configure DNS and DHCP. Now do one thing, take a rest for some time. This is going to be your diagram now. So host has to access google.com from ISP, and host is having a private IP address which are not allowed over internet. So now let's have the console of all these devices now. Customer edge, and also ISP. This is your host. F0/0 IP address is going to be 1.10. New IP default gateway is going to be nothing. The point is, as you know, that customer will always be having, as you know, this is customer as router and must have a default route towards an ISP. Do you understand? So now let's try to communicate with. Of course we cannot, because ISP will not allow your private IP address, and this time there is no reverse path, right? I haven't configured any ACL and all, something like that. So, and one more thing, it is not always correct to say, or it is not always right to say that okay, netting would be just used to access an internet only. No, never. Netting is just used to translate your addresses. We always say that whenever a packet will go from source to destination, its source IP and destination IP will never get changed. But there is one condition, that netting must not be configured. If there is netting, then definitely netting can change, can modify your source and destination IP address. So now let's say that we have got a public IP address over here, which is 101.1.2. Let's say we got it. This is static public IP address, and make sure that this static public IP address belongs to this subnet only, which is configured in between customer edge and ISP only. If you are getting an IP address from the different range, then how will it be possible for ISP to reflect traffic towards you? No, never. Because now if ISP request to transmit data towards 101.1.2, it will transmit that traffic out from FA0 by 0, and finally it will be received by customer edge router. Right? Fine guys, this is your public IP address that you got over here. Now, if you talk about the NAT, in NAT we are having various types of netting: static NAT, dynamic NAT, PAT, static PAT. You understand? So we have policy NAT. All these things, I mean, all these types of NAT are available here. So we will go via each and every type of NAT one by one, right? So this time you can see that I'll start from static NAT, right? One more thing. If you are going to configure a static NAT, remember that a static NAT is bidirectional NAT. Static NAT is what? Bidirectional, which means that your lane user can access internet, and from internet you can also access your lane user. Because a static NAT is always known as bidirectional NAT, right? So this time I will move on to customer edge router, and onto F0 by 0 I'll say IP NAT inside, then interface FA0 by 1 I'll say IP NAT outside. Now what is the difference in between inside and outside? What is the difference in between inside and outside? Don't say that okay, inside onto lane interface and outside onto WAN interface. Inside means that first of all it will perform routing lookup for the destination IP address of the received packet if it was successfully done. If lookup was successfully done, successfully performed, then it will translate its it will perform translation. It will perform, but first of all it will perform lookup for destination IP address, right? If you take outside, first of all it will translate first, and then finally it will perform lookup in its routing table for the destination IP address. Means that if you are taking inside onto an interface, then it will perform lookup in its routing table first, and then after it will perform translation. If you take outside, then it will perform translation first, then after it will perform routing lookup. Have you understood it or not? And it is mandatory. It is mandatory to take inside onto F0 by 0 and outside onto F0 by 1. Because if packet is coming from the host, source will be its own private, destination will be directly public IP address, right? Destination will always be public. CE, customer edge router, will receive it onto F0 by 0. If it receives it onto FA0 by 0, then it should process that packet. In that case only if it is having the destination address in its routing table. If it does not have default route in its routing table, should it perform netting? Should it perform netting in that case? Never. It should not perform netting in that case if it does not have the destination
IP address available in its routing table. So first of all, it will perform lookup, and if lookup was successfully done, it will perform translation according to your statement, right? Then after, it will transmit it out from F0 by 1. Whenever packet will come back from the internet back to you, at that moment source will be Google address 1111 and destination will be 101.1.2. Customer edge will receive it onto F0 by 1. If it perform lookup first, it will come to know that this address does not, this address is not directly configured onto me, and it can discard this packet over here, right? Because its own IP address is what, 101.1.10. It is not 101.1.2. Are you getting my point or not? It can discard your packet. But if you have taken outside, it will perform translation first. It will perform translation first. So your destination was 101.1.2. It will translate it back to private IP address, and then after lookup will be performed, so that it will transmit it out from F0 by 0 now. Right? Understood? So in this way you can explain your inside and outside. Then after configuring these commands, say show IP NAT statistics. Inside outside, you can see that, right? IP NAT inside source is static. When source is 1.10, then it should get changed in 101.2. That's it. Right? Listen, fine guys, so now after giving this, say inside global is what? Because I took my public address as 101.1.2, inside local is what? 192.168.1.10. Fine guys. Now do one thing, move back again onto host and try to ping with 1111, and this time you must be able to communicate with that. See? Right? And now say enable password is Cisco line VTY024, password is what? Cisco. Then go back to ISP, and from here try to take telnet of 101.2. You will not access your remote device with using its private IP, never, from ISP, right? You will be using its public address. So we took .2, right? Is not it? We have accessed. So it has proved that it is bidirectional net, right? Static net is what? Bidirectional.
So इसमें ARP जैसे बहुत करता है मिलेगा
What? Of course. Because ARP works in between, I mean, onto a single segment only. Fine guys. If you wanna configure dynamic net.
सर अगर मैंने ब्रॉडबैंड का मुझे पब्लिक आईपी पता है, मैं यहाँ से एक्सेस करना चाहता हूँ मॉडर्न,
You can do that. You can do that if you have user ID and password.
वो तो है, बट
You can do
वो
that.
कभी टूटता ही नहीं करते।
That might be, they have some restrictions over there. ISP kind of firewall and all. So IP address, see, I have configured all these things now. Then after it, you can also go for dynamic net, right? To configure dynamic net, as I know that I'm having, let's say, I got one pool of public IP address from 2 to 101.1.5, right? So you can move onto customer edge, and then you configure this command, just remove it. First of all, create a pool, IP net pool. Let's say its name is Cisco or CCIE, and then its start IP address is 101.1.2, and then end IP address is 101.1.5. Then it will ask for subnet mask as well. net mask 255 dot fine. Then after creating this pool, say IP net inside source pool source. What's that? Yes. You have to create one ACL, right? Access list 1 permit 192.168.1.0. Then it's welcome mask, and then say IP net inside source list is what 1. Then pool, and pool name is CCIE. Now first come first serve. Basis on that, it will allocate a public address to. I mean, now maximum 3 users can 3 or 4 users can access internet simultaneously, because you are having only 4 addresses available in your pool, not more than that. So now if you move on to host, and you can try to ping with that. So here you can say show IP net translation, so you will see that it will get C101.1.2, right? It got it 101.1.2, but this is not bidirectional. If you are on ISP now, and if you are trying to access 101.1.2, what is this? Clear IP net translation. Stop. Just wait. Show IP net. Just wait. Translation. Now do one thing. Once again, it will ping with that. Yes. Say show IP net translation. I think I have not removed that command static. Do show run pipe section. Let me show you IP net. I didn't remove that previous command. I think so.
It's not clear.
Why? Okay, this time it got changed. Show IP net translation. That's the problem actually, that from ISP, then how will you specify that it is 3 or what, right? So sometimes it will get .2, sometimes it will get 3, right? So that's the problem. But if you know that, okay, it was allocated during translation, then you can access that from here as well, right? From internet as well. That's the problem actually with it. Now, finally it is PAT. So do show history, just remove it. Even you can also remove your pool. And that's fine. See, show IP net. Statistics, nothing. Only IP net inside and outside are configured. One more thing. This time you got only you don't have anything actually. This time you don't have anything, and you have to configure PAT, right? PAT is completely unidirectional. It's not bidirectional. But in PAT you can translate multiple into a single public IP, right? So you can say IP net inside source list 1 interface fast Ethernet 0/1, and then overall. That's the only thing. I already created this ACL. That's why I was not required to create that ACL once again. See, and IP net inside and outside are also pre-configured over here. Show IP net translation. No translation, but if you move there, then you can see that there is translation, right? But now it's not possible for you to access it from there, from ISP, like telnet 101.1.10. How can you do that? You will be accessing the telnet of customized router itself, right? So now customized is there.
सर पैट के अंदर अभी क्या है कि जितने भी मेरे होस्ट हो वो सारे एक्सेस कर पाएंगे, लेकिन जो हमारा डायनेमिक नेट था उसमें पूल के अंदर जितने
exactly Even you can also use pool in PAT as well, like in this way. Let me remove this overload command from here. Yes.
तो इसमें सेशन वगैरह क्रिएट होने वाले हैं।
Yes.
तो उसके अंदर नहीं होते सेशन क्रिएट डायनामिक नेट।
In dynamic net, it was allocating a particular IP to a particular public IP to a private IP, as we saw. That's why we were able to access that public IP from the internet as well, right? Now see, create one pool, IP net pool. Name is CCIE. Start IP address is what? 101.1.10, and start and IP address is also .10. Net mask. Sorry. Now say IP net. So let's enter pool. Name is, and then you can say. So in place of calling interface, you can also call your pool. And now also you can access. See. Show IP net translation. But the problem is it is unidirectional. It is not bidirectional. Now, if you configure static net for each private IP, you will require a particular public IP. In PAT, it's unidirectional, it's not bidirectional. That was the problem. So to solve that problem, actually they launched static PAT. Static PAT. Static PAT. Do show history, remove everything from here. But IPNet inside and outside are still configured, right? Show run interface F0 by 0 and 0 by 1. See, right, guys? And this time I'm going to configure static PAT. Static PAT.
Bidirectional.
Yes, static PAT will be bidirectional. Means that with using a single public IP address, you can access multiple hosts from internet. From internet. Right? In static PAT from internet, you can access multiple private IP addresses with using a single public IP. I'm going to prove that. I'm having only one public IP address over here, which is 101.1.10. Right? What will I say? I will say IPNet inside source is static, because this time we are going to configure static PAT, right? Static what? TCP, UDP, or what? Let's say I want that from Google I must be able to take telnet of host 1.10 with using public IP address 101.1.10 itself. So I'll be saying TCP, then it will ask me inside local address, which is 1.10. Then it will ask me inside port number, which is 23, because I want to take telnet, right? Then it will ask for inside global, which is 101.1.10. Then it will ask for global port number, let's say 8001. So if you configure this command, what will happen that whenever I will access this IP address with this port number from internet, I'll be taking telnet of host 1.10. Let me do that. I'll move on to and then press enter. Let's go. Is not it? Yes. Now IPNet inside source. Let's say that you are also having some other private IP addresses as well. So static TCP 192.168.1.11.23 101.1.10, but this global port number must be different. 8001. Sorry, 2. Let's say this time it is 2. In same manner, if you are having some other server, some other devices as well, like with IP address 2, then just change their global port number how can you verify it that okay, now you can access them? Right now, if you go there and if you use like port number 2, you won't be able to access anything because that IP address 11 does not exist in this network anywhere, right? Do one thing, just change your IP address onto host itself. Configure its IP address as 1 dot. Oh my god. And see, once again, move on ISP. You see, you must be able to take telnet. Now change its IP address with 12. Make it 12 now. And then try to take telnet from there with using port number 3. So you must be able to take telnet of that. So see, you are using only single public IP address, right? With using that single IP address, you are accessing multiple private IP addresses now, multiple servers. Hello? That's called static PAT.
मतलब हमने private IP को एक port number से
Exactly. But see, you can take only telnet. You can take only and only telnet.
अगर हम लोग वहाँ पे सिर्फ TCP ही वहाँ पे mention करते हो,
What?
जब हम लोग ये command assign
Yes, then you can access anything, any service related to TCP over there. Like here, if you are saying IP NAT inside source static, and then I took TCP here, and then inside address is like 1 dot. This time it is using 12, and then I said local. Previously also I took, I think, TCP here. Yeah, I took TCP. You have to take port number, right? For each service.
अच्छा
For each service you have to take the port number, right? Let's say that I want to access HTTP. So HTTP will be using 80, and then your global, I mean inside the global IP address 101.1.10, and then any port number like 8005. So whenever you will try to access it, then you will be having, I mean you can open the web page. I mean you can access web server.
मतलब एक system के लिए एक ही service हम लोग access
No, you have, who said? You see, let's say that only one system is providing services for telnet, for HTTP, for HTTPS. For a single system you can create multiple entries now.
Okay.
Because for TCP, for each service, port number will be different. Right? That's fine. So this is called a static PAT. So in this way, what? IPNet inside source. You can also take route map. If you're taking route map, that's called policy net. Like you can match your interface. You can match your interfaces. You can set your interfaces. So if you are using here route map, let's say you took test, and then of course after that you have to define either interface or pool. Just to match your traffic, you can use your route map. And if you are using your route map, that will be known as policy net. You understand? That's it. Fine. That's done. Finished.